All right. So here we have sequences. We have two sequences, and we're going to write them in explicit form, right? Explicit form is a great form to write these in because let's say we want to find like the 150th term of this sequence. With explicit form, we can go right to that 150th term. The first part I got to start out with is how we label sequences. And with explicit form, and there's a little bit of variation with this, depending on the situation, it may be different. But with explicit situations, I want to start numbering at 0. And this is kind of the notation that you use like a sub 0 for like the 0 term, right? And a sub 1, a sub 2, a sub 3. The weird part is this is the first term, the second term, and the third term, right? And so on. So a sub 2 is actually the third term, right? Just here, it's going to make our life so much easier if we just start counting from 0. But if they ever use the terminology term, like the fourth term of the sequence, the fourth term of the sequence is going to be 24. Every time with explicit form, I'm going to suggest that we start with a sub 0, right? So we kind of have an idea on how to write these equations. One of them is going to be written in a very exponential way. One's going to be written in a kind of a linear way. And the difference between those two are going to be if the function's arithmetic or geometric. This one right here is geometric. It's geometric because it grows with multiplication, or sometimes multiplication disguised as division, right? It's multiplying by 2 each time. This one right here is arithmetic, right? And it grows with either like addition or subtraction. So if you take a look at these two sequences, let's see if we can write it. Now, geometric, we're going to write like it's exponential. So if I was to write this as a function, I'd say, okay, well, it's going to be something like this, right? Where I start with some number and I have some common multiplier. Well, here I start with 3 and my multiplier is 2 each time, right? To get this in explicit form, it's a small little thing. I'm talking about a sequence, right? And so I want to find not just like a sub 0 or a sub 1. I want to find a sub like any one, right? This just means anything inside the sequence. That n is my variable, and I just put this right here, right? That way, if the question was to ask me, I don't know what a sub 4 is, right? See how all they did was just change that a to that into a 4? Well, that tells me that what I want to do to find a sub 4 is to plug in a 4, change this in right here. 2 to the 4th is 16. 3 times 16 is 48. And you can see if I was to continue my pattern, right, a sub 4 would be 48, right? So I can use this to find, like, just skip right to, like, a sub 100, right? And all I have to do is plug 100 into there, and I can immediately calculate it. If we look over here, the arithmetic one, same kind of deal, right? This one's written linearly. So when we write linear equations, we wrote them like this, right? Where this number right here was my starting value of 5, and each time I'm going down by 2, so that will be like my slope. Well, the same changes kind of hold true. If I want to write this as an explicit sequence, right, just the notation changes a little bit. I'm just going to say I want to find any one in there, and I'm going to change this to this. That way I could like double check a value. Like if I wanted to confirm that a sub 2 really was 1, all I'd have to do is say, okay, I want to calculate from my equation what a sub 2 is. Well, I plug in a 2 for n. That means that all I need to do on this side is plug in a 2. So I get negative 4 plus 5. Guess what? That's 1. Right? So that works. Kind of one that needs a little bit more explanation is maybe you have a function like this, right? Let's actually do like this. Okay. I can tell that this is going to be geometric, right? Because this doesn't go down by the same amount each time. Like here, if I subtract these two, it's only going down 2. This one's going down 6. This one's going down, well, more than 6, right? So it's going down by some constant factor. One way that a lot of people see this is it's dividing by 3 each time, right? Now, since it's geometric, I know I'm going to write my function like this. The question is what goes where. I start off with 27. That's my starting number in the sequence. Assuming that I start labeling at 0, which, once again, every time I do explicit, that's probably what I want to do. Now, I want to get dividing by third into here. I mean, theoretically, I could do 27 divided by 3 to the n, and that would work. But we want to start writing everything in terms of multiplication. So dividing by a third is the exact same thing as multiplying by 1/3. Right? And that's the notation we want to use. If it was dividing by 10 each time, we would just multiply by a tenth. If it's divided by 17, you guessed it, 1/17. And that's going to be the slickest way to do it. So once again, explicit form is a great form, especially if they said, like, hey, for this sequence, what's a to the 50th? I don't want to divide by 3 over and over and over again. What I want to do instead is just plug a 50 in for there to figure out what a sub 50 is.